Some of these are pretty easy. Some of them are a little bit more difficult. So, solution concentration. So there's different ways to represent concentrations that they talk about in chemistry. Okay, the main one is molarity, and molarity is moles over liters. Moles of solute over liters of solution. You got to be really careful when you're crossing out units or when you're trying to figure out values that you pay attention to specifically what the units are within what you're trying to find. Okay, you got percent by mass. Okay, and that's mass of solute. So this would be more like everyday biology, every day looking at percentages. And so we can figure a mixture of a solution, percent by mass. We take the mass of the solute divided by the mass of the solution. Of course, they have to be the same unit. Grams or kilograms or whatever. It doesn't really matter as long as it's the same unit. Then we got percent by volume. So this would be liquids, that we're combining liquids. And so we can have volume of the solute over the volume of the solution. Oh, that needs to be times 100, by the way. So volume of solute over the volume of the solution times 100. So biology, again, they'll say like a 10% saline solution. Probably going to be pretty... If it's 10% saline solution, it's probably by mass. Okay, but if it's like an ethanol mixture of ethanol and water, it'd probably be percent by volume. Because both of them you can measure a volume. Okay. Another thing that we've got to really keep in mind when you do this is the density equation. So I'm going to put it up here real quick. Density is equal to mass over volume. So sometimes you might have to convert the volume from mass, and other times you need to convert from mass to volume, either way. So sometimes you got to say, hey, this stuff has this mass, I need to find its volume, if it's a liquid. And so sometimes they'll say, well, this is the volume, I got to find the mass of it. And that all kind of enters into these equations. Okay, we've got mole fraction, called the mole fraction. And a mole fraction is moles of solute over total moles. So this is looking, these other ones, well, percent, volume, and mass, of course they're dealing with liters and mass, and then molarity is moles. Mole fraction is both of them moles when you're comparing a sample. I think we did a little bit of that, but it doesn't. It's not times 100. The next one, the last one, is molality, kind of like molarity because molality. We used to do a lot more with molality, but the AP curriculum says don't do as much with molality. And so there's some labs we used to do in the past. That's a little m. So little m is molality. So little m, this is of course a capital M, molarity. So little m is moles of solute. The only thing that's different is it's not divided by liters of solution, but kilograms of the solvent. So it's just comparing it to the solvent that it's dissolved in. So the question is, why do you need molality and molarity? Well, there's this concept called freezing point depression and boiling point elevation, which what happens if you mix in like salt into water? We know it freezes at a lower temperature. That's why you put salt on the woks. Okay? Because when you put salt on the woks, even though the temperature is still below freezing, it will melt because wherever the salt is, it's very highly concentrated. And the higher the concentration has a lower freezing point, and so it's going to melt at a lower temperature outside. Same with boiling. you increase the boiling point too. So as you add more seasoning to water, it will raise in which the temperature takes to boil. Okay, so it's this called molality. It's something we used to use a lot in the past. And used to do a lot. Okay, I'm going to take a question out of the book. You do not have to have your book in front of you, but I'm going to give you some information, and we're going to have to calculate some values based upon those 5 methods to determine. Basically, we have to convert from one to the other if we've got enough information. So that's what we're going to do. All right. So we're going to have a solution, and we're going to have a solution. We're going to have 1 gram of ethanol. Ethanol's C2H3H5OH. And we're going to put it with 100 grams of H2O. Okay. And then it's going to have a final volume of 101 milliliters of solution. So we're going to have a volume of 101 milliliters of solution. So first thing we're going to do is we're going to find molarity. So find the molarity of the ethanol. So molarity of ethanol. So we're finding the molarity of ethanol. So what do we need to do? Moles of ethanol. So we got to take the 1 gram. We got to add this all up. It's going to be 46.08 grams per mole. Okay. So go ahead and do that. Find the molarity of the solution. Okay, so you took the 1 gram and you multiplied by 1 mole over 46.07 grams. You got an answer of 0.0217 moles. So you take the 0.0217 moles of ethanol and you divide it by liters. Got 101, so that's 0.101 liters. So that should give you the molarity of the ethanol solution is 0.215. Questions on that? That's molarity of ethanol. Okay. Next thing we're going to have you find is the mass percent. Find the mass percent of ethanol. Alright, so mass percent is mass of solute, which is the ethanol, over the total mass times 100. That one's pretty easy because you got all the information. So you take the 1 gram of ethanol and you divide by the total number of grams. And so I'm going to show it like this because some students tend to make a mistake on this. I'm going to take the 1 gram of ethanol and add it to the 100 grams of water. And that would be 101. So 1 divided by 101 times 100. The percentage is 0.99%. Ethanol. Any questions with that?
The the equation you gave us is massive solute over the massive solution.
Yep. So your mass of your solution would be the solute plus the solvent.
Yeah, doesn't it say?
So the mass.
Because the next thing says 101 milliliters of solution. Is that just the volume of the same thing?
That's the volume of it. That's the volume of it. So yeah, be careful. We want to just do with grams. Sometimes, depending upon the density. Now the density would be about 1 molarity, right? Or density would be 1 in that case, right? If I took the 101 grams divided by the 101 milliliters, my density is still 1 gram per milliliter. Sometimes it's not going to be that case. Sometimes the density is not going to be 1 because we're not dealing with, a lot of times, just water. Okay, if that makes any sense. So like, that final volume could be something totally different.
If it was something different, it doesn't affect the mass percent?
No. If you know the masses, it doesn't. Now, it might affect your volume ratio. But I'm not going to ask you one with volume on this one. Okay. Mole fraction. That's the next one. So, we can go ahead and do mole fraction. So that's moles of solute over moles of, total moles of solution. So, I think we've already figured out the moles of solvent, right?
Yeah.
0.0217. So we already have that. Now we just got to find the moles, total moles of our solution. So water has, there's 100 grams of it, and we know water's molar mass is 18.02 grams per mole. So we already know that we have 0.0217 moles of ethanol. Now, what we do is we take the 0.0217 moles of ethanol and we add it to the moles of water. So we got to find the moles of water, whatever that is. And then that's going to divide out, and that's going to give us our mole fraction. So, we take 100 grams of water, divide by 18 grams, so 1 mole, and that gives us the moles we have of H2O. And then we add it to the 0.0217, which doesn't add a whole lot to it. That's 5.54 we'll add it to. And then that will give us our mole fraction. So 0.0039. And that's the mole fraction of ethanol. So times that one by 100.
What's the label for that? Do we have
It's just 0.0039 mole fraction of ethanol. And the way they label it is, or ethanol, they label it X C2H5OH. And they say that that's equal to 0.0039. It's called a mole fraction. That's how you do it. Okay? And then the mole fraction of water is like 0.9, 0.9961. But they usually want solute. And the last one that I want you to do is find the molality. So Next one's molality. Next one. So you got to have. Oh, we already found our moles of ethanol. That's got that again. Now we got to divide it by the kilograms of solvent. In this case, kilograms of water, right? So what's our kilograms of water? 0.1.
0.1.
So it's 0.1, and so our molality is 0.217 molality. So you got to be really super careful on each one to make sure your units are right, and you're dealing with. A lot of times students kind of get mixed up solution and solvent. So sometimes students will go, well, I'm just going to put the mass of the solution. No, you cannot put the mass of the solution. It has to be the mass of the solvent that you use. It can't be the mass of the solution. How do you find a mass of a solution? Let's say that, let's get a scenario here where we do one more for the molality that gives students trouble. Okay, and I'm just going to try to set up an example of where we're going to end up with trouble. Okay, involved with it. Okay, and it's with molarity. So, and converting it to molality. So let's say that we have a solution that is 0.531 molarity of NaCl. Okay, so say we have that, and so that would be 0.531 moles of NaCl over a liter of solution. Okay, so let's say it's water. Okay. All right. So if I had to find the molality from that, I already know the moles of solute. Okay, that's the 0.531. Okay, 0.531 moles of NaCl. Okay. All right, I got a liter solution. Well, that's not the liter of the solvent. So it's like, how do I find liters of the solvent? Okay, so let's say usually they give you more information. I'm going to give you this additional information. I'm going to say the density of the solution is 1.22 grams per milliliter. Okay, so that's the density of the solution. And we're supposed to come up with volume. Okay, so that gives us, we've got to find the volume of water.
Are we finding molality?
Yep.
So don't we need kilograms of solvent? Not liters?
Oh, yep, sorry. Kilograms. Sorry, kilograms. Yep. So I got to find kilograms of solvent. Okay? Well, if I have a liter of, let's say I've got 1 liter of solution. Okay, so I can find the total mass of my solution if I have a liter of it, right? Okay, so I'm going to go here, down, I'm going to go for every liter, I have 1,000 milliliters. For every 1 milliliter, I have 1.22 grams of solution. Is that right?
Yeah.
Okay, so I multiply that out, and basically I get an answer that's 1,000 220 grams of solution. Okay. Did everybody see what I did there? Okay, I'm using the density to find the mass, total mass of the solution. I know the moles of NaCl. Okay, how many grams of NaCl do I have? So I go back and I go, okay, I'm going to take the 0.531 moles, and I'm going to figure out how many grams of that 1,220 grams is actually NaCl. So I'll put 1 mole here, and up here I'll put 58.45 grams, that's what salt is. And I will get the mass of just NaCl. So then I can subtract that mass from the total mass of the 1,220 to get the mass of the solvent. So I'll go, okay, 0.53 times 58. That gives me 30, I'm going to say 31. It's 30.97. I'm going to say 31 grams of NaCl. Alright, so there, I'm going to go to that, and I'm going to subtract out, because the solution has NaCl plus water. So if I subtract out the 31 grams, that's going to give me my mass of my solvent, water. Okay, so I go ahead and do that, subtract, and then I convert that to kilograms. And then I can divide it out. Kind of a lengthy process, or it seems like a lengthy process. 1189. So then that is 1.189 kilograms, and I've got my answer once I do that. So that's the toughest one for students to do, because there's a lot of, seems like, steps to that process and thinking through the process. So the molality of this solution is 0.45 molality of NaCl. Okay, so just real quick again on that one to finish things up. So they give me a molarity here. I know the moles of that, so I put the moles of NaCl, and then I need to divide that by kilograms of the solvent. Okay, so then what I do is I'm given the density of the solution. I can go through and find the mass of the total solution, salt and my solvent. Then I subtract out my salt once I find how many grams I'd have based upon the moles. Subtract it out. That gives me a new mass that would be converted into kilograms, and then I can find my molality from that. All right. So tomorrow when you guys come in, you guys have an opportunity